Hello, this is Mariah and Sherry, and we are presenting our project for Dr. Ames's GIS programming class at Brigham Young University. Our project is called What's Shakin' Baby, and it is a script that will run within ArcMap to calculate risk of hazard for earthquake events across the state of Utah. So the map that will be generated will look like this and have the the risk calculation for each event that the user specifies within a year range. This is what the final maps look like. As you can see, the script will output one PDF named with the start and end years defined by the user. We applied a common symbology and risk classifications so that the events could be easily compared across different areas and times. As you can see here, for example, this event had much higher risk rating than this event. To get the common symbology, we set the colors we wanted for within a raster that had the values 1 through 10, and then exported the color map. The exported color map is a text file that has the raster cell values followed by the corresponding RGB values that should be applied to that raster value. So here's the tool interface for our script. As you can see here, the user can define whatever start and end year they want to download data for. They input a DEM, define an output directory and workspace geodatabase, and then load in the color map file. This is a .clr file. So this is all the user needs to do, and the script will automatically download the data and process it through the geoprocessing. We designed the geoprocessing using Model Builder. It's a relatively simple model. We took the shake intensity data as a CSV file and ran it through the Make XY Events layer tool. This plots the data in ArcMap, and then we interpolated using IDW. We interpolated the peak ground acceleration across the area for which the data was taken. We clipped the DEM to that area and then calculated the slope for that area. The risk calculation is just the slope multiplied by the peak ground acceleration. This output risk raster we reclassified into 10 discrete categories so that risk could be more easily compared from one event to another. We exported this script, or this model, as Python script, and that formed the basis of our geoprocessing script. And Sherry will now explain the rest of the script.
Okay, here is a whole Python script of this project, and I'm going to walk through it to show you what we've done to achieve those functionalities. And at the beginning, this is a license of our tool, and it is free to use according to MIT license. And with the ArcGIS model we built, we got a Python code for the geoprocessing part. And we know the only thing we have to import to a model is a CSV file. So what we have to do next is how to get the earthquake data in CSV format. And here we defined two functions to do this. The first function is a fetch file function. It can download data from the website with the event ID of the earthquake and save it as a CSV file. So we thought that the user may not familiar with the event ID of each earthquake. So we defined this getEventID function here. So let's look at this function first. So at first, we found that this website lists all events occurred in Utah as a table list here, including the date and the event ID and other information about the earthquake. So we define this function to allow user to define the years interested, and the function will go through this table list and find the data in a range of select years, so that the user only have to select the start year and end year, not a specific event ID. So let's look at the function. The URL is where to get the earthquake list. Then we open the URL and read the HTML and parse the table list. Here we import a Python module named Beautiful Soap. It is a Python library with functions that can extract data from HTML files. We use try except here to avoid the website change or there's no table exist on it. This part is how we parse the table list and get all the data with a Beautiful Soap service. Then we just extract the year and the event ID from the table and save to a list. And in the end, for each event ID in the list, we run fetch file function to get the CSV file for each event. Here this is a fetch file function. At the beginning, the URL is where we download the earthquake data, and we will define where to put the CSV data. So at first, we will check if the CSV file is already exist, because we don't want to download it again if we already have it. Then we open the URL and download the zip file and unzip it to a folder, and then we will get the XYZ file. Let's look at the XYZ file here. So the XYZ file is like a big array list, and each line is an element here. So we just read the XYZ file line by line and split each line with space and save them as a list. Then we write the list into a CSV file. That's how we get a CSV file. After we get a CSV file, we delete the unzipped folder and the zip file and just keep the CSV file. That's what we need. Now, through this loop, we can get all the CSV files in the selected years. And then we have to run geoprocessing for each CSV file. So we define the risk calculation function to connect the CSV file to the geoprocessing part. And most code in this function are from the ArcGIS model. Also, we add some code to make it work well and for debugging. Like here, we found that there are some events occurred out of the extent of the DM. And the ArcGIS will crash if this happens. So before we clip the DM, we add some code to check here. and it will jump over it and give warning to the user. And after the geoprocessing part finished, we define the symbology template here and set a transparency to 25 to give a better vision. At the end, this part is how to export the results to a PDF file. So here is the main program of this Python script. And you can see at first it can read the parameters from the tool interface and create a PDF file and run the get event ID from the user input start year and end year. Then we get the CSV files, and for all the CSV file, we will run a loop to run the risk calculation function for each CSV file. At the end, we compile all the PDF files into one PDF file and named with the start year and end year. And that's all about our project. And thank you for watching this video, and hope it will help you. Thank you.